Hello everyone, this is Ali. If you're a .NET developer like me, and if you spend enough time in LinkedIn, you must have seen lots of posts that tell you how to throw an exception or how not to throw an exception. There are lots of confusion over exceptions. What are those and blah, 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 blah. So in this video, I'm going to be talking about exceptions. I will tell you what the exception is, when do we throw, how do we throw, and if we throw it in a right way, what happened? If we throw it in a wrong way, what would happen? I'm going to show you all of these. But before we dive into it, I want you to stop this video, pause this video, and hit the like button. And if you have any question in your mind, if you have any feedback to my channel, please let me know in the comment section below. And if you haven't subscribed the channel, please do it. It helps. It helps the channel more than you think. Now let's talk about exceptions. Okay. Exception is a simple object in C# that we use for when we create something like software, but that software doesn't behave how we want it to behave. Let's say there's 5 lines of code, and the exceptions are that's something that happened in the code, but not something you would expect it to happen. It also might be possible that you can expect, so you can create your own flow to throw an exception, say in an exception. But again, exceptions are something we don't want to have in a normal way. When everything is correct, we don't want any exception in our code. It's because it says exception. It's something I don't know. It might be something I know, as I just said. Exceptions can be caught. We can throw an exception, we can catch it. There's a special keyword in C# to catch it, like catch in a try-catch block or something. So exceptions are normally a simple object, but depends on how you use them. It can be a bit confusing. Let me show you what the exception class look like actually. So if we get into exception class, we will see it has a message. The message is what is the exception? So what happened that we didn't expect? And also, as we see, it has inner exception. We'll get into it in a minute. We have stack trace. We will be talking about this. Actually, message, stack trace, and inner exception would be the most of it. So what we're gonna do today. But if we want to create an exception, it is that way. For example, that exception. But we might have different exception. Depends on what the exception is. For example, if you are trying to access an non-exist index of any item in an array, so you would get out of range exception. If you don't know anything like in your server, that's something that you don't know, maybe you just return internal server exception or something. Maybe there is something wrong with your arguments to any function, you might just throw an argument null exception, argument exception. Maybe there's something null and you're trying to access, then you might get null reference exception. So there might be many exceptions, depends on what the exception is. You can create your custom exceptions as well. I'll be showing you. But exception is a simple class that carries some messages in it. For example, if we have any exception, not this one, maybe this one. For example, if we have an exception, we can throw it, and the keyword for it is throw. We can throw a new exception, or we can throw the exception already created. In this case, for example, just throw and throw X, I'll be showing you. If we throw a new exception, and if there is any catch block, then the code itself is going to flow through the catch block. So when the second that I executed that line, the code will hit in this here, in the curly braces over here. So now I will have a block where I can do something with exception. For example, let's say the exception can be printed like exception.message, so I'm able to access its properties like that. In this case, for example, the original message has set to invalid operation exceptions or a property, let's see, a message. But if you see, there is an exception over here. This means if any exception occurs in this block, I want to catch it. But you might just say, okay, this is invalid operation exception, but this is exception. And you are totally right. If we go to invalid operation exception, you would see there is system exception, and then it goes exception. So basically every exception you create is an exception. It can be system exception, but also in a base class you might think it is exception. It is derived from exception, so you can catch it by using this. But you also you are able to invalid operation exception. You can also have a specific catch block for any exception you throw, any specific exception. But I may not move that one to here. It's simple exception. It's because it checks if this one is exception. If not, so if else, it is going to do the same over here. It tries to find if the exception type matches. But in this case, as every exception is exception, it is going to be on that catch. So that catch is going to catch all the other exceptions. So that's why if it is something special we want to catch, we do it first. And this is basically the else block in if else blocks, if you think. So this is if and this is else. So else needs to be at the end. Okay, let's see what else we can do. In here, for example, if I have, let's say I just needed to print it onto console and I want to rethrow it. What does it mean? So in this case, there's an exception occurred over there, but I need to do something with that, like maybe logging. Maybe you're just writing all the information that you have in the exception to the file, maybe database, maybe just you call some other function. But also you still want to notify whoever is calling this function needs to catch that exception again. In this case, I need to catch it, but I will have to rethrow it. We can rethrow it within different ways. So that's where we get confused actually. There are multiple ways to throw an exception, but if we choose the wrong way, we might lose some data. So let me show you how we can do that. For example, if I say throw X here, which means there's a note over here, we lost the stack trace. But let me show you something over here, exception printer print. It basically prints the exception in a nice way with the color, like red color with the exception and the message just blue and then the dark blue. And then we have a yellow here for stack trace. So if you remember in exception, we had inner exception. Let me show it to you again. We have inner exception there and its type is also exception, which means exception can have any other exception in it. It's because we have layers in our applications, right? So one layer throws an exception, says, okay, maybe user not found. And there's another layer, catches that exception. It just does something. Maybe that layer needs to rethrow the exception. But when we rethrow the exception, someone catch it, what are we going to lose the first exception we throw? Maybe user not exists. Are we still going to be able to see it? Or just are we going to have the latest exception? So we can create an exception and set its base exception, inner exception with something else. And if you use throw X basically, which means I have an exception I caught here and I want to throw this. When I throw this exception, for example, in here I will catch it. But the exception I catch here is this exception. Do you think this exception is going to have original error message, for example, if I try to print that? So let me call that function here. I'm now calling throw exception. So I'm going to throw this one. I will catch it here. Let me get rid of that. I will catch it here. And then I will rethrow that exception, the one I just caught. And I catch it and I print. So I'm printing this one. So let me get that off now. Like that. And when I run the app, what are we going to see? That rethrow an exception and print it out. As you see, let me bring it back. As you just see, throw X, this is where it comes from. And the message is original error. So I've seen that original error. And the exception type I caught is invalid operation exception. But you can say, okay, we throw the X here, so it's exception. But remember, it is actually base class check. So it is still invalid operation exception here. And the message itself is original error. And if you see, we have line 2, so line 65. which is over here where we throw the exception. So we print we print the exception that we caught here, right? So I see everything. There's another way here. And let me bring this back. So this is invalid operation exception. This is original error, and then the everything. Let me rerun the application and see. Did we print? Yeah. So there's now 2 exceptions. In this case, as you see, we use throw X. So we throw specifically that exception, and also we say just throw. But there's something that I want to show you. So the line is 65. It says, okay, there's an exception. There's a program in line 65 that is an exception occurred, and line 65 is this. And when I throw without specifying any exception, it also says line 65. That is weird. I see again invalid operation exception, original error. In this case, for example, I can tell you I've seen the same message. So original and original, invalid operation and invalid operation. Let me show you a few other examples. As I just said, we might have layers, different layers. As we have only one layer over here, it didn't matter if we throw the X or if we just throw. It didn't matter in this case. But let me show you another example. So layered exception example. And let me show whatever here. So let's say you have a repository, user repository, and it says user not found exception. So yes, I have created my own exception, user not found exception, derived from exception, and also here user service exception that has been thrown by the user service. In here, for example, the repository, when I call the repository, it throws user not found. And in user service throw, I call the repository, it throws an exception, I catch it. As you see, if user not found exception throws, just catch it. And then I throw new user service exception. Remember, user service exception by setting its inner exception that user not found exception. Remember, so I have now created new user exception, user service exception, but also says the exception I caught here should be inner exception of this one. So basically, throw an exception, catch it, create new, but set the caught one into the new. So, and the note says preserves the stack trace. Stack trace means in your exception, there is inner exception. The stack trace means if I have the previous exceptions details in my stack trace, in my inner exception, right? So in this case, I am now setting its inner class, inner exception, by saying X. This is throw. It throws. But there's not over here. We'll come to that later. And in user throw exception, what it says, okay, I call the user repository. It throws user not found exception, and I catch it. And I throw that exception I just caught. But don't remember, it is still user service. I throw an exception here, catch it, I throw that exception. In this case, so what I have here, I call user service throw, just throw, and catch any exception thrown here, and print it. It says stack trace with throw, okay. And in the second example there, I'm now calling X. Remember, this was the one throwing only the exception it caught. It didn't include the other one. And it says stack trace with throw X, and then it prints it. Let me print that. So let me get rid of these and put that on and run the app. Okay, first what we see is the exception type in the first example. Let me show you here. The exception type is user service exception, right? It's because I call the user service exception, but also it says I have inner exception, says user not found exception. So I was basically able to generate a new exception, but also save the previous exception into that one. I have now all the stack trace, so I can trace all the stack back to where is the original. And it also says, okay, this is the stack trace text, but it also says there is one exception thrown in 159 over here. If you see user service not exception found, and also 89. So there's something called 89 here. So the original, so now I can trace all the stacks. So this one throw an exception that is being thrown in like over here, and I'm able to catch it. It shows me all the stack trace. And again, I have inner exception, user not found. So user not found exception has been thrown, but the actual exception type I called is user service exception. It's because I was able to create that one. But in the second example, if you see, it doesn't have any inner message. Let me show it to you where it was. So throw X. So it doesn't have any inner repository. And also it says line 100 is being thrown. So here, okay, it is right. And also 179, 73, sorry, 173 here. So the exception, it just got that one. But in the inner exception, I don't know. So it says the user not found in repository, but what I get is user not found exception. If you remember, what I did was here, I called user service exception. So technically in my user service layer, I had an exception, but as I throw the exception that it catch from its repository layer, I have user not found exception. Do I want to have this one only, or user service exception has been thrown the last exception, but also it tells me what was the previous exception, which was user not found exception. So this is the whole confusion. This is the whole you need actually. If you have a layer of layer, and if you do the try catching mechanism between these layers, if you just throw the latest exception, you might just use the last one. Over there, so I said throw. So let me catch that. And what do you expect to see when I throw this one? Do you think we are going to have repository 2 or just user not found exception as it was? Let me show it to you. Nope. And nope. Let me rerun that. In this case, if I don't create a new exception but throw whatever I have, so it is going to throw the exception it caught. But if this one had, let's say this one had inner exception, it is going to include that too. So if that throws an exception, let's say, so it create user not found exception, but it also says, let's say new, just exception. Inner exception, it says, okay, this doesn't accept other one. So let's say exception, it accepts and pass it to the inner exception. So this one, okay, this one now has inner exception, right? And then this one, we just catch it here. So this has inner exception, don't forget. And I am throwing this. So let me show if we have something different. As you see there, now the second approach that I just made over here, also if you use throw, also says inner exception, right? So we have the exception that says inner exception. If I say just use that one here, right? Does it change? No, it's because I'm now throwing this one. So if you have exception, inner exception in this, you may just throw an exception, that exception specifically, or if you say throw, you don't need to worry if it has inner exception in it, or maybe you're just gonna lose it. So throw is always the best option you might have. But if you're just gonna create another exception on top of that, you are going to have to include that one into this one. So when I throw new service exception, it is going to include that one, but this is also include another one. So now I'm keeping the stack trace same, right? Let me show you another example. So user service, user repository. And again, depends how you throw and how you throw. If you throw only or throw X, it is going to include the whole stack trace or not, depends of the exception that you catch and rethrow. In here, I can tell you there are a few types too. So as I just said, we can create a new exception and include the other one as an inner exception. But there is something that we can use, ExceptionDispatchInfo. It basically is the similar thing. So you can throw a new exception, you can capture it, and it is going to give you a new exception here, right? So this is ExceptionDispatchInfo, and you can throw this one. So for example, I created new exception type. I have created exception dispatcher info by just passing the exception, and I can throw this one. And you may just think that exception dispatch info is a collection of exceptions. And when you throw, it basically does the similar thing, that it includes the whole inner exception into that one and something. So I have now new exception dispatch info. I can throw that one. When I throw that one, it says stack trace is preserved. Why? It's because I set the exception, what I catch, the one I catch here, and I add it into my exception dispatch info. When I throw it, it's going to have everything it needs from that exception. And when we print it, we are going to see it. Or there is a special exception type. We call it AggregateException. And then AggregateException is, again, collection of exceptions. So you can catch, add into that one. You can create a new aggregate exception or something. For example, task run returns aggregate exception. So if you have, let's say, more than one exception into that one, in that aggregate exception, it's in inner exceptions, you're going to have all the exception that is being thrown, that is being created within this aggregate exception. So this is a special sort of exception. If we get into that one, again, you might just say, okay, it has inner exception, but it is read-only collection. So there can be more than one exception that we add into that exception type. And now this is where we catch, and maybe you just want to loop through all the inner exception and print those. So let me show you that example. So here it says original error, dispatch info. This is what I got from original one. So 123, 114. It just shows where the exception has been thrown. And in the aggregate exception, so I use task. It's because I know task run, if it throws an exception and if there's multiple exception in that one action, it aggregates all and throw aggregate exception. It's because in the run, task run, we provide one action here. There might be more than one exception, like say repository exception, user not found exception, user service exception or something. Multiple exception can be thrown, and it is going to aggregate them and give it to me when I say, okay, if there's an aggregate exception, I want to know what is the inner exceptions. And it says there are exceptions there. So line 134, different than these. And also it also tells me what the exceptions are, like something. If we had more than one, we would also see that, but it is also preserving all the stack trace that happens in the task run action, we can say. Okay, now we know what throw does, what throw X does, what aggregate exception does, what is exception dispatch info. This is a bit old fashioned, I guess, exception dispatch info. So you can capture any exception into that one. It returns that info and you can throw that. And we know what throw does. We know what throw X does. So depending depends if you know your exception has inner exception or not, you may want to choose either throw or throw X. But if you're unsure, to preserve the state trace, you should always use throw. It's because if we had something else into that one. This is all from that video. If you have any other question regarding throw an exception and catching the exception, and doing all the catch when or pattern or something, let me know in the comment section below. If you haven't subscribed to the channel, please subscribe. Until the next video, happy coding.